Hey guys, welcome back to eCoreAcademy. My name is Anita Raj, and today I'm doing a new lesson for my Algebra 2 course. So before you start watching this video, I would like you to pause, like the video, and also subscribe to our channel so that you can be notified of our latest uploads and so that you can follow along with this Algebra 2 course I am doing. I already have a playlist up on the channel with all the videos I've done so far organized sequentially. So if you're trying to either review this course or learn it ahead of time before you actually take it in your school, please follow that order. That's the order I learned it when I was in Algebra 2, and going in that order will be most beneficial for you. So let's get into the lesson I have planned for today, and it is systems with 3 variables. So this is the first part. I'll be posting the second part later on, but this is the first part, and we're going to be tackling how to solve these 3 variable systems. We'll be learning what they are, and we'll also be doing a review of 2 variable systems. So solving systems with 3 variables. So your three variables are going to be x, y, and z. If you remember from Algebra 1, where you learned solving 2 variable systems, you only had x and y. Now we're throwing in that z, and you'll see exactly how it's applied and where the z comes from. So let's get right into the video. So before I even get into 3 variable systems, for those of you who have taken geometry after Algebra 1 and are going into Algebra 2 now, you guys might need a refresher of what 2 variable systems are. So let's go over the systems with x and y, just 2 variables from your Algebra 1 days. So if you guys remember, there were 3 methods to solving these systems. There was graphing, elimination, and substitution. And you guys might have learned them in whatever order, but I'm just going to go over scenarios where you have 3 of them. Instead of actually walking you through how to do each of them, I thought let's actually do a problem together and maybe jog your memory. By doing a problem, we see directly how it's applied to these systems. So we're going to be taking each method and we're going to do a problem with it, and then hopefully you'll remember how to do these. So for graphing method, we're going to do graphing method first. So the question's asking us, can you solve the system by graphing? Remember, we're going to be doing a review of 2 variable systems first. So can you solve the system by graphing? So the 2 equations we've been given are 2x plus 4y equals 12 and x plus y equals 2. And I have the solution down here in dark blue, so let's follow along exactly how we solve this. So for graphing method, when you're given 2 equations, you want to graph them both on the coordinate grid, and the point where they intersect, that coordinate is your answer. So in order to do that, you want to change 2x plus 4y equals 12 to y equals negative 1/2 x plus 3. You want to do this so it's in the form y equals mx plus b, slope-intercept form, so it's easier for you to graph. So the way I did this was I wanted to get 4y by itself. So I subtracted 2x from both sides. So then you get 4y equals negative 2x plus 12. Then you divide by 4 to get y by itself, and you get y equals negative 1/2 x plus 3. So I just shorthanded it and just took you directly to the answer. You also want to change x plus y equals 2 to y equals negative x plus 2. You did this because you want to get y alone by itself, because you want slope-intercept form, and you subtract x from both sides, so you get y equals negative x plus 2. So that's how you get to that answer. So then I kind of just skipped ahead a few steps because you should be able to graph those 2 because they're in slope-intercept form. I graphed them on a coordinate grid right over here. And then you can do this by hand, or if you have your TI calculator, feel free to go to your y equals and type both of these equations in, and then hit your graph button and then find the point of intersection using the calc menu like I've showed you in previous videos. And then the intersection, that coordinate is your solution. So the point where these 2 intersect is negative 2, 4. So that the answer to this system would be negative 2, 4. Okay, so we solved 2 variable systems with the graphing method. Now let's solve them with the elimination method. So can you use the elimination method to solve the system? 2x plus 3y equals 12 and 5x minus y equals 13. So I just did this by hand, so because it was just easier for me that way, and I've drawn arrows and just kind of showed you the entire process. So we have these, so I first wrote out the 2 equations were given in this system. 2x plus 3y equals 12 and 5x minus y equals 13. So we have these 2. With the elimination method, you want to pick one of the variables and you want to eliminate it. So you want to get rid of that variable. You can multiply the whole equation by a number to get rid of that variable, or you can just do it however you need to. You can manipulate the equation as much as you need. Just make sure it is still equivalent to its original form. Eliminate that one of those variables. You're left with only one variable. You can solve for that variable and plug the value of that variable back into the equation so you can find what the other variable is. Let me show you what I'm talking about. So here, when you look at these two equations, you have 2x plus 3y equals 12, and you have 5x minus y equals 13. So if I have to pick to eliminate either the x or the y, and I chose the y because if you see, this is plus 3y, and I multiplied the whole second equation by 3. So if I multiply this whole second equation by 3 times 5x is 15x, negative y times 3 is negative 3y, and 13 times 3 is 39. If you guys come over here, in elimination, you add both of the equations together. And if you see, because I multiplied this times 3, now my negative y times 3 is a negative 3, and these two 3's cancel out. The positive 3 from the previous equation, and now the negative 3y from the second equation, they cancel out. So these two cancel out. 2x plus 15x is equal to 17x, and 12 plus 39 is equal to 51. I got rid of this y, so I don't have to worry about it anymore. And now since I have one variable, I can solve for it. So if I divide 17 from both sides, I get x equals 3. So now I know what my x coordinate is. I can take the x coordinate, and I just pick the first equation and plug it back into the first equation as x, so I can find out what y is. So I plugged it back into the first equation. I did 2 times 3 because x was equal to 3. 2 times 3 plus 3y equals 12. 2 times 3 is 6, so you get 6 plus 3y equals 12. You subtract 6 from both sides, you get 3y equals 6, and if you divide 3 from both sides to get y by itself, you get y equals 2. So if you put them together, your coordinate, as in your final answer, would be 3, 2. So that's how you use the elimination method to solve two variable systems. And now finally, let's use the substitution method. So can you use the substitution method to solve the following system? X plus 3y equals 7 and 2x minus 4y equals 24. So with the substitution method, you pick one variable and you pretty much manipulate the equation so that you get, let's say I pick y as my variable. So you get your x to the other side, you get all the other numbers to the other side, so you get y equals some quantity, and because y equals that quantity, you take that quantity and you plug it in for y in the other equation. I'll show you exactly what I mean with this problem. So first, you want to change this. So I first took this x plus 3y equals 7, and I wanted to get x by itself. I wanted to find a quantity even if it had a variable that's equal to x. So I changed x plus 3y equals 7 to x equals negative 3y plus 7. So I just subtracted 3y by itself from both sides, and I got x by itself. So now I know that the quantity of x is equivalent to the quantity of negative 3y plus 7. So we wrote x in terms of y. So now you have to plug what you found for x into the other equation. So now I know x is equal to negative 3y plus 7. So doesn't that mean I can just plug negative 3y plus 7 into x in the other equation? So if you remember the other equation, 2x minus 4y equals 24, there's an x right next to 2. So instead of writing x, I can take this this negative 3y plus 7 that I found to be equivalent to x, and I can just plug it in instead. So now I substituted x with negative 3y plus 7. So now I have 2 times negative 3y plus 7 minus 4y equals 24. And if you see here, what we did was we got rid of the x and we put the y in there, and we wrote it in terms of y. So now we can solve for y since we only have one variable we're working with right now. So then you distribute the 2 and you get negative 2 times negative 3 is negative 6. 2 times negative 3y is negative 6y, 2 times 7 is 14, and then you get minus 4y equals 24. And then you do negative 6 minus 4y, you get negative 10y, you still have that plus 14 equals 24. Then you subtract 14 from both sides, you get negative 10y equals 10, and y equals negative 1. So now we know that y equals negative 1. However, we have to plug this back in to find out what x is equal to. So if you come back over to this side, where my cursor is, you have to plug y back into the equation to find x. So we're going to take that original equation, the first equation, x plus 3y equals 7, and then we're going to take this version of it that we converted to x equals negative 3y plus 7. We're going to plug negative 1 in for y so we can find out what x is. So x is equal to negative 3. Instead of y, we wrote negative 1 because y is equal to negative 1. X equals negative 3 times negative 1 plus 7. Negative 3 times negative 1 is 3. X equals 3 plus 7, and then 3 plus 7 is 10. So x is equal to 10, and your final answer is the coordinate, so your x and your y. So your answer is 10, -1. So that's how you would solve two variable systems using the substitution method. So now that you've reviewed it with me, how to solve systems, two variable systems with graphing, elimination, and substitution methods, hopefully that's jogged your memory and you're ready to go with solving three variable systems. So again, you're going to be understanding a system where you have the variables x, y, and you're also adding that third variable z. And here the process changes a little bit, and I'll be giving you some background information on what three variable systems are. I'll be walking you through the process of how to actually solve them because there's a more specific process, and then we'll actually be doing two practice problems together. So no worries at all. So what are these three variable systems? So they're graphs of equations that include three variables and are represented by planes. So they're graphs of equations. So you still have three equations, but now in these three variable systems, you don't have two equations, you have three equations this time, and in each equation, you have three variables, not two variables. So three equations and each have three variables, x, y, and z. So that's what we're working with now, and they're represented by planes. So planes are pretty much these two-dimensional surfaces that go on forever, if you remember from geometry. They're pretty much the intersection of multiple lines that form this surface, that two-dimensional surface that just goes on and on and on. So we sometimes use planes to understand three variable systems. So if you guys look over here to these three pictures, you can see that these are planes. So like this red part, this orangish part is a plane, this teal part is a plane, and this cerulean part is a plane. So if you see, these planes are intersecting. So therefore, the solution to a system with three variables is the intersection of these three planes. So where these three planes meet, that intersection is the coordinate that is the solution. So if you remember from two variable systems, we had an xy coordinate that denoted the answer. So the answer to a two variable system would look like -10, 1, -5, 2, -100, 200. We would write it as an xy coordinate. So the similar situation with three variable systems, except we write it as an ordered triplet, which means we write it as x, y, z. So we would write -10, 2, 5. So just instead of just two, your x coordinate and your y coordinate, you have an x coordinate, y coordinate, and then z coordinate. So you just write it as an ordered triplet. So if you guys look at these pictures again, like here, you have multiple intersections. Like these would denote the answers. You have intersections here, but you don't have any intersections here. So these all right here, they represent scenarios, and when you have no solution. When all three planes are touching at a point, that's when you have a definite ordered triplet solution. And we'll see what those are. Again, I will put this link in the description if you want to check out where Lumen Learning, where they discuss this. I'll put this in the description if you just want to take a look at these pictures and see those no solution scenarios. So what are they? I'm just going to continue off of what I just said so you guys get more background information on what three variable systems are. So we'll be looking to the third situation that I just mentioned. So the third situation is when they do intersect, the intersection of three planes at a single point where you get one definite answer. So if you guys want to know what a three variable system looks like, I know I kept telling you three equations, three variables each, but if you see where my cursor is, this picture right here, this is what a three variable system would look like. So if you see, you have three equations right here, but then you have three variables each. So you have x, y, z, x, y, z, x, y, z. So three equations and three variables each. So this is what a three variable system would look like when you're given a problem and asked to solve it. So in three variable systems, we will be specifically using the elimination method. For that's just how the process works. That's how I was taught, and those are the steps I'm going to show you on the next slide to follow. They're all based around the elimination method. Because you're working with three variables, you want to eliminate two of them so that you can work with the third one, and then you can just work backwards, and you can use even the substitution method when you're working backwards, or the graphing method, but we'll use the elimination method principally. It's all this, the way you solve these is built off of the elimination method. So you guys have to make sure you're pretty solid with the elimination method. So it's pretty much the same thing we're doing in two variable systems with the elimination method. Like I said, you have to make sure you're pretty strong with the elimination method, and you'll be totally fine with solving these three variable systems. So let's go through the process. I'm just going to put it in a bulleted list for those of you who just like to read through instructions and then approach a problem, and then we'll be doing two problems together by applying this process. So let me just quickly run through this list with you guys. So first, you want to, if you have three equations and you're trying to do a three-variable system, you want to choose any two equations. So you can choose the first and the second and the third, or the first and the third, and then you want to pick one variable to eliminate. So then you want to return to your original system and choose a different pair of equations. So let's say you pick the first and the second equation, and then you eliminated your x. You eliminated your x variable. Then you want to return to your original system and choose a different pair. So let's say you pick the second equation and the third, and you want to eliminate that same variable. So you eliminate the x again. So then you should now have two equations. So from eliminating from the first and second, and then from the second and third, you'll have a fourth equation and then a fifth equation. You should have two equations with the same two unknown variables. In this case, because we eliminated the x variables, you would have y and z. Again, you can pick any variables you want to, just be consistent. So then you would take your fourth equation and your fifth equation, and then you would solve this system using any method you want. We used elimination method, but again, because now you have simplified it to two variable systems with your fourth equation and your fifth equation, you can use any system you want. You can use substitution, graphing, elimination. So then once you do that, you should be able to narrow it down to one variable, and you should be able to find the value of that variable. Let's say we eliminate the y's, and then we find out what z is equal to. So once you have that single variable found, you have to begin substituting it into the other equations. So then you want to find out what the other two variables are. In this case, we found z. So now we want to find out what x and y are. So then when you're done doing the whole system and you find out what x, y, and z are, you write your solution as an ordered triplet in the form x, y, z, as mentioned here. So just like a coordinate, parentheses, x, comma, y, comma, z, each of corresponding value. And then your solution can be checked by simple substitution. So if you plug each of these values for x, y, and z into the actual variables in the original system in each of the three equations, you should be able to get the actual answer. So it should just use the original system. You can pick one of the equations. You can try in all of the equations. Just make sure both sides of the equation are equal to each other after you plug the values you have put in the ordered triplet back into the variables. So if you're a little bit confused, I can totally understand. We're going to be doing actual problems where I wrote out each step, so I can guide you through them and you can see exactly how this process is applied. So we're going to do example number 1. Can you solve the following system? X minus 3y plus z equals negative 4, 2x plus 3y minus z equals 15, and 4x minus 3y minus z equals 19. So there's so the way you organize it is totally dependent on you. When I see these three variable systems, there's a particular way I've kind of trained my eye to organize it. It's very important to stay organized and label your equations 1, 2, 3, 4, 5, etc. when you're doing these, so that you don't get your equations messed up. So make sure you stay as organized as possible, especially if you're one of those people who works pretty messy. You must be organized with these three variable systems, or trust me, you will get them wrong. Okay, so first what you want to do is you want to write each of the three equations you've been given by the problem. So the first one, x minus 3y plus 3z equals negative 4, I wrote it right here. Then I wrote my second equation, I labeled it as 2. I wrote 2x plus 3y minus z equals 15. And then I wrote my third equation that I was given, 4x minus 3y minus z equals 19. See how I wrote 1, 2, and 3 in front of them so I can stay as organized as possible. Then you want to decide which variable you want to eliminate. You can pick x, y, or z. For this case, I just said y, and at the top I wrote eliminate y to remind myself of that. Then I chose to I decided to first use the first two equations. So I picked the first one and then the second one. So then I wrote them here like I would in an elimination method. I wrote the first equation, which was x minus 3y plus 3z equals negative 4, and I wrote my second equation, 2x plus 3y minus z equals 15. And again, remember, I'm trying to eliminate my y, so I'm going to be focusing on my y's. Lucky for me, I have a negative 3y and a positive 3y, so I don't need to multiply either equation by anything. I don't need to manipulate it. It's already set for me. So these two already cancel out. So I'm simply going to add these two equations together. X plus 2x is 3y, negative 3y plus 3y is 0, so that cancels out the y. Positive 3z minus z is positive 2z, and then this equals a negative 4 plus 15, which is just 11. So this is what I come down to after eliminating the y from the first two equations, and I would write 4 right here because this is my fourth equation. So if you guys remember, you get two equations after after doing the first chunk of this process, and I'm going to label this as my fourth equation. So then remember, I have to repeat this process, but I have to pick two other another two equations, like a different set of equations from my original system. So then for the second time I did it, I picked the second equation and I picked the third one. So then I wrote them down here: 2x plus 3y minus z equals 15. And then I wrote the third equation: 4x minus 3y minus z equals 19. And see how I label them? I keep labeling them so I don't lose track of which is which. So then I'm trying to eliminate my y's again here. I'm staying consistent. I still want to eliminate my y's. And lucky for me, the same scenario is here. I have a positive 3y and then a negative 3y. So they cancel each other out. I don't need to manipulate my equations or multiply them by anything. So if I just simply add them, I get 2x plus 4x is 6x. Positive 3y minus 3y is just cancels out. And then negative z minus z is negative 2z. And then this equals 15 plus 19, which is 34. And again, this is my fifth equation. So I did elimination method with my second and third equation from my original system, and then I came up with this fifth equation and I labeled it 5. So then after you do that, you want to take your fourth equation and your fifth equation, and you want to either do elimination, substitution, or graphing, because now you've narrowed it down to a two-variable system. So I just stuck with elimination method, and I wrote my two systems right here. My two equations right here. The fourth equation, 3x plus 2z equals 11, and then the fifth equation, which was 6x minus 2z equals 34. And I lucked out because look, the z's cancel out. Positive 2z cancels out with negative 2z, so I don't need to multiply or manipulate anything. So then you just simply add the two equations. 3x plus 6x is equal to 9x. The z's cancel out, and then you just get this equal to 11 plus 34, which is 45. I want to get x by itself, so I divide both sides by 9, and I get x equals 5. So now I found one variable. So what do I want to do now? So I want to plug this back in to one of my 5 equations to find out what figure out what a second variable is. So right now, after you find out your first variable, you want to pick either your fourth equation or your fifth equation, because see, these both have x's, so we would technically just have the x already in there. We already know the value of x, so we'd be solving for z. So you just want to pick either your fourth or fifth. For this scenario, I picked my fourth equation, so I rewrote it here by substituting 5 in for x. So 3 times 5 plus 2z equals 11. See how we're trying to find the value of z now. So we're gradually working to find each value. So then 3 times 5 is 15 plus 2z equals 11. I subtracted 15 from both sides, so 2z equals negative 4. Then I want to get z by itself, and I divide both sides by 2, and I get z equals negative 2. So now I know x is equal to 5 and z is equal to negative 2. So now what I can do is I can pick another equation. So what I did here was I picked another equation where I just picked the first equation right here, because you need to pick your original for the last and final variable. The final variable you're finding is the first variable that you eliminated. So in this case, my last variable I'm finding is y. Well, y was the first variable I tried to eliminate with my first 3 equations, which were the original equations of this 3-variable system. So I need to pick one of the 3 original equations up here. For this scenario, I just picked 1. So my first equation. So x is 5 substitutes in for x in this case, so it's 5 minus 3y. We don't know what y is, we're trying to find it, plus 3 times negative 2, because remember, z is equal to negative 2. So we can substitute negative 2 in for z equals negative 4, and we just simplify this. So 5 minus negative 3, 3 times negative 2 is negative 6, so it's 5 minus negative 3 minus 6 equals negative 4. Then we do 5 minus 6, and we get negative 1 minus 3y equals negative 4. Then we want to get negative 3y by itself, so we add 1 to both sides, and we get negative 3 equals negative 3y equals negative 3. To get y by itself, we divide by negative 3, and we get y equals 1. So we now write our answer as an ordered triplet. Remember, x, y, z. So x is equal to 5, y is equal to 1, and z is equal to negative 2. So this would be your final answer down here that I boxed. So that's how you would solve this 3-variable system. Let's look at example number 2, which is a little bit harder. So this one's asking us, can you solve the following system? And the system they've given us is 2x plus y minus z equals 5, 3x minus y plus 2z equals -1, and x minus y minus z equals 0. So these are the three equations they've given us. So first what I did was I wrote out the three equations and I denoted them with a number 1, 2, or 3 so I could stay organized. So I wrote the first equation, 2x plus y minus z equals 5 here. I wrote my second one, 3x minus y plus 2z equals -1 here. And I wrote my third, x minus y minus z equals 0 here. So then I had to decide which variable I want to eliminate, and I picked y. You guys can pick x, y, or z, but in this case I picked y. So then what we do next is we pick two of the equations from the original system. So I picked the first one and the second one, and then I put them down here so I can do the elimination method. So I wrote the first one, 2x plus y minus z equals 5, and I wrote the second one, 3x minus y plus, I know this is 2x, but I just wrote it in a box right here. It should say 2z. So 2z equals -1. So I wrote that down. So next, we have to decide how we're going to eliminate. Lucky for us, we're eliminating y, and here we have positive y and negative y, so these two cancel out, so we don't need to multiply or manipulate the equations in any way. So then what we just do is we just add the two equations. So 2x plus 3x is 5x, the y's cancel out, negative z plus 2z is equal to just z, and then 5 plus -1 is equal to 4. So then we have our fourth equation down here, 5x plus z is equal to 4. So then we have to repeat the same process by picking another set of two equations from our original system, and I picked the second one and the third one for the second time. So I wrote the second equation again, 3x minus y plus 2z is -1, and I wrote the third equation right below it, x minus y minus z equals 0, and we're going to do the elimination method on it. And we're trying to eliminate y's. However, if you look here, we have a -y in the second equation, and we have a -y in the third equation. These two don't cancel out. We need one to be a positive and one to be a negative if we want it to cancel out. Therefore, you have to manipulate one of the equations in this scenario, and that's what makes this problem a little bit harder. So I picked the first equation, and I multiplied the whole thing by -1. By multiplying the whole thing by -1, it's still equivalent to the original equation, but we're manipulating it so that we get a positive y. So if you see, if we multiply the whole thing by -1, we get -3x, because -1 times 3x is -3x, -y times -1 is, now we got a positive y plus y, and then 2z plus -1 is -2z, and this equals -1 times -1, which is 1. So this is our new equation right off here to the right. And what we do is we would add this new equation to the third equation. So -3x plus x is equal to -2x. These two y's now cancel out. This is a positive y, the other one's a negative y, and then -2z plus -z is equal to -3z. And lastly, 1 plus 0 is equal to 1. So our fifth equation, we've solved it by manipulating the second equation, is -2x minus 3z equals 1. And as you guys remember, now we have a two-variable system, and we are going to do in my opinion, I'm just going to do the elimination method. You can do the substitution or graphing. So now I have these two, the fourth equation and the fifth equation. I'm going to do elimination on them. So I wrote the fourth one, 5x plus z equals 4, and I wrote the fifth one, -2x minus 3z equals 1. And in this case, I really can't get rid of either variable because they're just not compatible like the other ones. So first of all, just start off by picking a variable to eliminate. In this case, I wanted to eliminate z. So in order to eliminate z, you compare the z's in both of the equations. So the z here is a positive 1z, and the z here is a negative 3z. So how do we change one of these z's to make it compatible with the other? Well, I decided to multiply the fourth equation by 3. So if I multiply this fourth equation by 3, I'm turning this z into a positive 3z, and positive 3z and negative 3z, they'll cancel out. So you have to kind of manipulate these equations so that they work, so that the variables you want to cancel out. So I multiplied this entire equation by 3. So 5x times 3 is equal to 15x. Z times 3 is equal to plus 3z, and then 3 times 4 is equal to 12. And now I take this equation off to the right, and then I do elimination method by adding it simply to the fifth equation. So 15x minus 2x is equal to 13x. These z's cancel out, and then 12 plus 1 is 13. So now I have 13x equals 13. And to get x by itself, you just divide by 13 on both sides, and you get x equals 1. And what you do is you just plug it back into either the fourth or fifth equation to find out what z is. In this case, I picked the fourth equation, so I did 5 times 1 plus z equals 4. 5 times 1 is 5 plus z equals 4. You subtract 5 from both sides to get z by itself. You get z equals -1. Then you pick one of the you either pick the first, second, or third equation, the original equations from our three-variable system. You plug your x and your z back in so that you can find what your y was. Y was the original variable we had eliminated. So I picked the third equation because it's just the simplest equation, and I plugged the x and z back in, and I left y so I could find y. So 1 minus y minus -1 equals 0. 1 minus y plus 1, because negative times negative is positive, plus 1 equals 0. Then I do 1 plus 1, and I get 2, so -y plus 2 equals 0. You subtract 2 from both sides to get -y by itself. Negative y equals -2. We're trying to find what positive y is. So we multiply both sides by -1. We get positive y equals 2. So now when we put all these answers together, we get the ordered triplet 1, 2, -1, a box down here. That is our final answer. So that's how you would solve the second three-variable system. It was a little bit harder, but we were still able to do it because we understood how to do the elimination method. So that's all I have for you guys today. I know that was a pretty long lesson, but that's why I chunked this into 2 parts, part 1 and part 2. In this lesson, we went over what the two-variable system was, and we went over graphing method, substitution method, and elimination method. Then I introduced you to how to do the three-variable system by hand. We went through the process, mainly centered around elimination. We also talked about what three-variable systems are, and we did 2 examples together. So I hope that was helpful. My next video will be actually how to do it on the calculator using matrices. Super exciting, but I want to save that for a separate video, and we'll do that together with a tutorial. So that's all I have for you guys today. As of now, please like the video and subscribe so you're notified of future content. Our website link is on the screen, and all this information, our socials, our website, our Gmail will be in the description box below. Our website is going up soon, and it has all these materials we don't have on the YouTube, so please go check that out. We're on Facebook, Twitter, and Instagram. Please follow us on those accounts and use them if it's easier for you to share our videos with your friends that way. And lastly, if you have any personal or business correspondences that you would like to keep private and not put in the comments, please email us at eCoreAcademy@gmail.com. We are open to advice, your feedback, anything. So please contact us. Don't feel afraid to do so. All right, guys, please stay safe during COVID, and I will be bringing you part 2 of this lesson. I'm super excited. See you next time.